Hello and welcome to this second part of my video review of chapter 7.3 about tidal ranges and tides. We are going to go into a little more detail about how features of the coast and features of the weather will affect the tides. As we talked about earlier in the earlier video, the moon's pull at the water and the sun's pull at the water create the tidal pattern we see. But how come then that we have some places where the tide is very low and other places where the tide is high? We have a high or low tidal range. Well, one feature that matters here is the shape of the coast. If I have a coastline here that is pretty much straight, like a beach, well, all the water will coming in during high tide will come in at a uniform level. This will mean that, given everything else is the same, the difference between high tide and low tide will not be extreme. On the other hand, if we have a coast where some factors make it easier for water to get concentrated, like if we have here an opening into like a bay. Well, in this case here, we have a lot of water out here coming in at high tide, which then will have to concentrate into a narrow gap, which will lead to a stronger currents and a higher tide. So the structure, the morphology of the coast really decides, among others, how strong the tide is. But then, of course, we have the difference if it is a spring tide, where this will be a really big tide, or a neap tide, where this, of course, still be a smaller tide. So the morphology of the coast affects how big the tide will be. Another thing that will affect how big the tide can be is wind. If we have a coast here, let's draw from the side, and this is my low tide, and this is my usual high tide. During like spring tide, if we at the same time have a strong wind blowing this way here, the water will be pushed in, so as the tide comes in, so does more water. And in some cases, this can lead to what we call a tidal surge. A tidal surge can be quite destructive if we have high tide and strong wind at the same time. We see that around Denmark sometimes, in Løgstør, when we have the wind and the tide at the right time. We see it in the west coast sometimes. That suddenly salt water will run in over land, and this can be quite destructive. First, when the water comes in and we get salt water in the field, which is not very healthy, we get damage to houses. And then when the water retreats, it can take with it chemicals, nutrients, other stuff, which can lead to pollution of the water system. So these are the two main factors that really affect how high a tide can get: the morphology of the coast and the direction of the wind. During a tropical cyclone, for example, we have a low air pressure as well. This can get even worse because this really allows water to swell and more water to push inland. So often during a tropical cyclone, we can see the wind blowing in, we have the tidal surge coming in, and if we then at the same time have a large rainfall at land, we can really get a lot of water damage to structures. Alright, thank you for being with me today. This was part 2 of my recap of tides. Again, the main point here is that tides are the gravitational pull of the moon and the sun affecting water movement. The morphology of the coast can affect how tides work. For example, in the Bay of Fundy in Canada, we can have a tidal range of up to 14.5 meters, where many other places in the world we might only have a tidal range of 1-2 meters. Wind and weather system can affect our tidal range as well and can lead to tidal surges. And if we have a tropical cyclone where we have a low pressure system, high wind, tidal surge and rain at the same time, we can see a lot of water damage to terrestrial structures. Thank you for being in this, hanging along for this video. I do apologize for the bad equipment and very small whiteboard, but this is what I have to work with now. I hope this helped you in some way, and I'll see you all soon.